Hello, this is the lesson on finding the average using the antiderivative. If we're finding the average of a set of numbers, we simply add them up and divide by the number of numbers that you have. And we could use this method if our data was discrete, which means no decimals, or if it was a linear function. However, if we're dealing with curvature, we'll need a different way. For example, if we wanted to know the average speed given a function, we need to know the total distance traveled. So, for example, if over the course of 2 hours your speed varied from 50 to 60 miles per hour according to this function, 50 plus 2.5 t squared, this right here is a parabola. You see it? It's got a curve to it. And this is from 0 to 2 seconds. To find the total distance traveled, this is a velocity curve, and so to find the total distance traveled, you could take the antiderivative of this function and evaluate it at 0 and 2 and then subtract using the fundamental theorem of calculus. That would give us the area under this curve. So given a velocity function, you can take the antiderivative and find the total distance traveled. Well then, if you know that you went from 0 to 2 hours, then you would just take that total distance traveled and divide it by 2. And so this idea is there is a way to find this area under this curve even though it's not a nice rectangle. So we use calculus to find the area under the curve, and it kind of levels. This rectangle here has the same area as this, and so finding the area under the curve just to then divide by 2 will give you the average velocity. So to find the average speed traveled over that 2 hours, you would divide the total traveled by the total number of hours, total distance traveled by the total number of hours. So in this case, for this function, it would be 106.67 miles divided by 2 hours, which gives you your average speed of 53.335 miles per hour. So this is the formula that we're going to use to find the mean of a function on a given interval, or the average of a function. What you're going to do is calculate the FTC of the function and then divide it by b minus a, or 1 over b minus a times the FTC. Okay, so this first example is sort of an example that sort of provide proof that this really does work. So we have the cost in millions of dollars of a 30-second TV ad during the Super Bowl in the years from 1988 to 2001 can be approximated by this cost function. And this cost function, notice, is linear. And t equals 8 represents 1988. So if I calculate the cost in 1998, 1998, and then 1999, and then 2000, and then 2001, I would get these values. And so if I want to find the average, I literally can find the average, which is you add up all of these values and then divide by the number of values that you have, which is 4. So that's the traditional way to find average. And you get, there's an average of $1.77 million per year. But there's another way to do it, and that's using the fundamental theorem of calculus. So if we set up a t and we want to know the average cost, what we're going to do is go from 8 to 11, and we're going to take the antiderivative of cost, which would be 0.355 times t squared divided by 2 minus 1.6 times t, and then evaluate at 8 and 11, and then subtract the upper limit minus the lower limit. And then remember, average is FTC divided by B minus A in parentheses, or you can just divide by 3. And you can see you get the same answer. And again, that's because this was linear and this was like discrete data, 8, 9, 10, not 8.1 or anything. So this verifies that this formula will work. And what's interesting is the units, the functionality of the unit sort of disappears for a minute. This is a dollar function, not a dollar per year function, it's just dollars. So when you take the antiderivative, it's sort of, the unit is kind of up in the air. But then when you take it back down, this average ends up being dollars per year. So that's what's going on with this one. And let's look at another example. This one says if you invest $8,000 at 6% interest compounded continuously, what is the average amount in your account over 1 year? And so this is the formula that we're going to use, is A equal P e to the RT. So this is, I don't have it written anywhere, so I won't go over here. This is, if we do the FTC method, we'll have T is in years, so we just want to know from 0 to 1, and the antiderivative of A equals 8,000 times e to the 0.06t. Better write that down for you, so I'll do that. Insert an equation. So if we plug in what we're supposed to know here, A of t equals, P is the initial value, 8,000, e to the, R is the interest rate as a decimal, 0.06 t. So that's our function. So the antiderivative of that function is 8,000 divided by 0.06 times exp times 0.06 times t. Keep forgetting my parentheses. It added it in there for me. Alright, so if I go to the right, and then FTC means find the area in the curve, subtract the upper limit minus the lower limit. And then if we want to find the average, it's going to be FTC divided by parentheses B minus A, which I know is just 1, but I'm just kind of helping you remember the formula by stating it over and over again. And so it's, if you invest $8,000 at 6% interest compounded continuously, what is the average amount, A, in your account over 1 year? Now, just to show you that this is the only method that's going to work when you have curvature, we can take a look, and I won't go through it in the key. I'll show you. We know the answer is right here. Make sure that's the same thing. Yeah. Using antiderivative to find the average amount is actually more accurate for nonlinear curves, since it will find the exact area as the width of rectangles goes to 0. It effectively levels out the area so that an exact average can be found. So let's say I don't believe it and I just want to find the average using the cost function without the derivative, 8,000 e to the 0.06t. So at 0 years you have 8,000, and at 1 year you have 8,494. So then if we add those up and divide by 2, we get 8,247.35. So it's kind of off. But let's say that I split this year up and go from 0 years to half a year to 1 year, and then I add those up and divide by 3, then that's my average, and it's 8,246.11. So we just got closer. Well, let's say from 0 to 1, I divided this up into fourths and found the amount at all those times, and then added them up and divided by 1, 2, 3, 4, 5. That's my average, getting closer to 8244. And then let's say I divided it up into 0.125s and found the amount after each year, part year, and then divided by 9. I'd get 8245, getting closer. Well, let's see if I divided the year up into 100ths and I found the amount, and then I took that, added all those up and divided by 101, I get 8,244.9. So you see how it's getting closer to this actual average value. And the reason that this doesn't work is because of this curvature in the data. But what I'm doing here is actually using the Riemann sums method, kind of. I'm breaking up the distance, the dx, into a bunch of triangles, and as my number of widths goes to infinity, the closer I will get to this. So this is the true way to find an average value if you have a function that has a curve in it. Okay, so something similar. $1,000 is invested into an account earning 2% interest compounded continuously. What is the average balance of the account in the first 5 years? So again, we have the continuously compounded interest formula. A equals P E to the RT. And so my function is A of T equals your initial amount is $1,000. E to the interest rate is 2%, so that's 0.02. Let's put parentheses around it. Times T. So that's my function. And I want to find the average balance. So I'm going to do it the calculus way, and I'm going to find the antiderivative and evaluate it from 0 to 5, and then divide by the interval. So from 0 to 5, we're going to find the area under the curve. The anti of A is 1,000 divided by 0.02 times exp to the 0.02 times t. So that's the lower limit and the upper limit, and then the FTC says subtract those two values, and then the average is the FTC, the area under the curve, divided by 5 minus 0, or just 5. And so your average balance in the account over the first 5 years is $1,051. So there's your formula. A equals PE, the RT. Take the antiderivative, find the FTC. Average is equal to FTC divided by B minus A. Okay, here's one. Suppose an object travels with a velocity in feet per second, given by v of t equals 10 over t on the interval 1 to 4, where t is time in seconds. First thing, it says find the exact distance traveled. Second thing, find the average velocity. So I like this question because you're actually going to need to know that you have to create a second function. And so we have to remember this. A distance function has the first derivative of a distance function is velocity. And the second derivative of a distance function is acceleration. Alright, so if you have a distance function and you take the first derivative, you will have a velocity function. And if you take the second derivative, you will have acceleration. Okay, so now you have to understand and go backwards. If you have acceleration, the first antiderivative would give you velocity, and the second antiderivative would give you distance. Well, here we're given velocity, okay, and we want to know distance. So that tells me I have to find the antiderivative of velocity to find the exact distance traveled. Okay, so step A is actually part of what you have to do for find the average. So the interval is 1 to 4, and we want to find anti-velocity, which is actually distance. So the antiderivative of 10 over t is 10 times natural log of t, and you don't need to worry about absolute value because our domain is defined and it's positive. And then FTC, we'll subtract the upper minus the lower, and that's this was in feet per second. This velocity is in feet per second, so this distance right here would be feet. So we know that from 1 to 4 seconds we traveled exactly 13.86 feet. Alright, then if you want to find the average velocity, simply take that FTC value, which is distance in feet, and divide that by 4 minus 1, which is 3, but I'm just going to let Excel do it. And this is time in seconds, so we have feet divided by seconds, which is feet per second, which is a velocity. So the average velocity is 4.62 feet per second. I don't think I'm going to do this one, but it says profits in millions of dollars, so this is an actual profit function. You would need to multiply that out, t squared minus 2t minus 1t plus 2, and then add like terms and then distribute the 6. So you would have to multiply this out first, because it says find the average profits. Average profits means takes the antiderivative of profits and then divide by 4 minus 0, because it says first 4 years. So if you want to look at that answer there, you can. All right, here's another one about velocity, and it says Rico's speed in miles per hour, t hours after entering the freeway, is given by v of t equals negative 1080 t cubed plus 540 t squared minus 22.5 t plus 60, but this is a velocity. You're given a velocity function, miles per hour. You're given an interval. Well, this is the domain, and questions are going to change. The first question says find the expression giving the distance Rico traveled. So again, you have to know that it goes distance, velocity, acceleration. So if we want to go back from velocity up to distance, you have to take the antiderivative. So that would be the first question. And then how fast was Rico traveling at 0.2 hours? Now we have two functions. Now we have a velocity function and we have a distance function. So what's this question asking you to use? It's asking you for velocity, how fast. And it's not a calculus problem. It's this velocity function says when you know the time, you know the velocity. So all you would do is plug 0.2 into that velocity function. Third question says how far did Rico travel between 0.2 hours after entering the freeway and 0.4 hours? So this means how far means you would use your distance function, which we found in A. And then D says what was the average speed from 0.2 to 0.4. So that means you're going to use this answer here, which is the distance from 0.2 to 0.4, and then divide, which is FTC, and divide by 0.2 to 0.4. So let me look at this answer here. This is your velocity function, and the distance function is the antiderivative v of t, and it's negative 1080 times t to the fourth divided by 4, plus 540 times t to the third divided by 3, minus 22.5 times t squared divided by 2, plus 60t. And you may be wondering, do we need the plus c? No, because we're going to be evaluating values here. So how fast? You would use the velocity function. So right here I have t and 0 and 0.2 and 0.4, and I typed in my anti-velocity function, which is distance, and I went ahead and typed in my velocity function here. So use the velocity function at 0.2 hours. So when t is 0.2, my velocity function gives 68.46 miles per hour. Question C, use the distance function because it says how far did they travel between 0.2 and 0.4. So I have the antiderivative here and here. Subtract the two, get the FTC. So between 0.2 and 0.4 hours, they traveled 14.25 miles. And then the last question, what's Rico's average speed? Remember that's an average, so you're given the velocity, but you remember you have to take the antiderivative of velocity, which is distance, get the FTC, and then take that FTC and divide it by b minus a, which is 0.2 minus 0.4. And so that's a miles per hour. So that's what 71.25.